Okay, so today we're going to talk about graphing quadratics in vertex form. So your objective for today is that you will be able to graph quadratic equations that are in vertex form by understanding the transformations from the parent function, which is what we're going to go through in this video. So the first thing I want to talk about is the parent function of a quadratic compared to the vertex form. So your parent function is just y equals x squared, which you should know when you graph it is just a parabola. So then your vertex form, we have a times x minus h squared plus k. So there's lots of things to talk about with this. So the first thing is what each of these letters do. So your k is what moves your parabola up or down. So if it's plus 5, it goes up 5. If it's minus 3, it goes down 3. Your h moves it left and right, but it's the opposite sign. So for example, if you had x minus 3, you see a minus 3 and you're automatically thinking it's going to move to the left because that's your negative side of the graph, but it's the opposite sign. So a negative moves it to the right. And if it was x plus 3, then it would move to the left 3. Your a, if your a is negative, so if this is a negative right here, then your whole graph is going to flip and point down. So your negative reflects your parabola over the x-axis, and it also can stretch or shrink it. So if your absolute value of a is greater than 1, so if it's like 2 or 3 or 4, your graph is going to get more narrow. Meaning that it's vertically stretching it because it's pulling it straight up to get more narrow, so it's getting taller as well. Then if the absolute value is less than 1, it becomes wider, so it's a vertical compression. Because since it's wider, it's getting flatter and shorter, so it's a vertical compression. So now also, let me change the color here. To find your vertex is just hk, since this moves it left and right, and your k moves it up and down. So, but keep in mind this h is also the opposite sign of whatever's here. So if you have x minus 2 squared plus 1, your vertex would be positive 2, positive 1. So your k keeps the same sign, but your h is the opposite sign. So we're going to look at different examples. So first, as I said, this is the graph of the parent function. So we're going to look at how each of these features changes your parent function. So we always start our graph at the origin here. So our transformations are going to be like transformations from the origin. Now changes in k. So your k is what's added or subtracted onto the end. It just moves your vertex up and down. So in this case, if you just have x squared plus 3, it moves up 3 units. And it's the same exact graph, just up 3. Now if we had minus 3, again, it's the same exact graph, but your vertex just moves down 3. Now here's where it starts to get a little more confusing. So your changes in h, as I said, it's the opposite sign. So right here we see negative 2, but it moves your vertex to the right 2 instead of to the left. So it makes your vertex, so if we have plus 0 for k, positive 2, 0. Now here we have x plus 2. Again, it's the opposite sign, so we're moving to the left 2, and your vertex would be negative 2, 0. This is an example of when our a is negative, so if our sign in front is negative, we keep the same vertex at 0, 0, but it just flips upside down or reflects over the x-axis. here's where it starts to get confusing for some people. So our absolute value of a, so just ignoring if there's a negative in front of it or not, is greater than 1. So in this case, it's 2. We have a vertical stretch. And if you see here, our graph becomes more narrow. So it's being stretched up taller. So the way to graph these, well, you can always make a table because you can always graph by making a table. But so if we have y equals x squared, if we plug in 1 for x, we get y equals 1. So our point is 1, 1. So if we look at this parent function, we have 1, 1 right here and negative 1, 1. Well, when you're vertically stretching it, you're multiplying that number by 2. So we get 1, 2 and 1, 2. So like if you automatically know that when we plug in 2, we would get 4 because it's just 2 squared. So instead here, we would have, when we go over to 2, it would be up to 8 instead of 4. So you're multiplying like what you would normally get by 2, or by whatever number's in front. Then we have y equals 1/2 x. This makes our graph wider and it's more narrow, so it's a vertical compression because it's getting shorter. So same type of thing, we get 1, 1 on a normal graph right here, but you would divide that now by 2, or whatever's in the denominator. So we get 1, 1/2. So before I also said it would be 2, 4, but now this 4 is divided by 2, so we get 2, 2 in this new graph. Your next point would be 3, 9, so it would be 3, 4.5. So you're just dividing by whatever's in the denominator. So it'll make more sense as we go through some practice. So we want to just look at the different pieces here. So first, we can find our vertex. So our vertex is opposite sign of this, so positive 3, and then exactly what this is, so negative 3. So we can go to 3, negative 3, and plot our vertex. Or you can think about it, if we start at the origin, this minus 3 on the end shows we're going to go down 3. And then this negative 3 means we're going to go right 3. So we get to our vertex either way. Now, we don't have any a value, so we would normally move from here over 1, up 1, over 1, up 1, and from 2 we go up 4. So now you can do that same exact graph here, because since we don't have a shrink or a compression, our parabola stays the same. It's just shifted down 3 and right 3. So we can also label different things on this graph, just like we did when we were graphing in standard form. So our axis of symmetry is at this x equals 3. Our vertex is 3, negative 3. And we can still find our y-intercept by plugging in 0 for x. So we get 0 minus 3 squared minus 3. So we get negative 3 squared, which is 9 minus 3. So our y-intercept happens at 6. So you could use that to help you graph too. And then because of your axis of symmetry, you can count it over to the other side. And we know that that's where our parabola is continuing on. So there's a lot we can still find. We can say that this vertex is a minimum because our graph opens up, so it's at the bottom. So let's look at some more examples. So right away, we can find our vertex, negative 2, 1, because opposite sign, same sign. So I'm going to go ahead and put a point at negative 2, 1. Now our graph is going to be reflected over the x-axis, so flipped, but there's no vertical stretch or shrink. So we're going to do our 1 up and then 4 up. And look, our x-intercept is right there as well. So that means our x-intercept, or y-intercept, I mean, is at 0, -3. Our vertex is at -2, 1. That means our axis of symmetry is x equals -2. And our vertex is now at a maximum because the graph opens down. Now we have an example with a vertical stretch where our graph is going to get more narrow because of this 4. But we can still start off the same way. This means our graph is moving to the right 1. This means down 2. So that means our vertex will be right here, or you could find it by doing opposite sign, same sign. 1, -2 is our vertex. It's going to open up because our A is positive. So now we have our 4. So normally we go over and up 1, but you're going to multiply that up 1 by 4. So we're going to go over 1, up 4. So we get right here. Same on the other side. And then normally you go up 2, over 2, and up 4. Multiply that up by 4. So we're going over 2 and up 16, which clearly will not fit on this graph. But we can make our parabola with these points. We see that it's more narrow because it's vertically stretched by a factor of 1/4. So it's always by a factor of whatever's the opposite here. So we'll talk about that more later. But right here we can see our y-intercept is at 0, 2. Vertex is 1, -2. Our vertex is a minimum because it opens up, and our axis of symmetry would be at x equals 1. Now we have one with a fraction. So this has a negative sign, a fraction in front, and h and k here. So we're seeing this is like the hardest one you'll have to graph. So we can start off. This means we're going up 3. This means left 2. So our vertex will be here, or you can look opposite sign, same sign. So our vertex is at -2, 3. It's going to open down because of this negative sign. So now where you would normally move down 1, we're going to have to divide that by 4. So that means it would be 1/4. I'm not even going to plot that point. I'm going to go to where we would have 2. So our normally we have 1, 1, 2, 4, 3, 9, 4, 16. So now we can divide these each by 4. So when we go over 2, we would normally go down 4, divide that by 4. 4 divided by 4 is only 1. So we're only going over 1. Or going down 1. 9 doesn't divide nicely, so I'm going to look at this 16. 16 divided by 4 is 4. So if we move over 4 spaces, we're going down 4, where we would normally be going down 16. And we graph it. It is much wider, which means that it was vertically compressed, because normally it would look something like this and be taller. We can say our vertex was -2, 3. Our axis of symmetry is -2. Y-intercept is 0, 2. This is a maximum because it opens downwards. I think that's about all we can say about it. So now we're going to have to describe the transformations. So instead of graphing them, we want to just look at it and see what happens. So we'll start off with the easy ones. We're going to say this translates down 9 units. Because this is always same sign, so it's down 9. And now we can mark that off. We're done that. This +6 is always opposite sign, so we're going to say it moves to the left 6. And then finally, we know we have a vertical stretch. So So I'm going to say vertically stretched. Now we always have to say by a factor of, and it's always going to be the reciprocal of the number. So by a factor of 1/2, since it's 2. So if this was like a 4, it would be by a factor of 1/4. Now over here, and that marks off all of our things, so we're done. Over here, I'm going to start over here, say translated up 2 units, since our k is a positive 2. We're going to look at our h, it's -1, so we're going, instead of to the left, to the right 1 unit. I'm going to look at this negative sign and say it's reflected over the x-axis. That's what you'll say every time there's a negative. And lastly, since we have this 1/3, it makes it wider, so it's vertically compressed. So vertically compressed. Always, once again, say by a factor of. And it's always, once again, by the reciprocal for this as well. So since it's 1/3, it's by a factor of 3. So if it said by a factor of, let's just say 5/2, you would flip it and it would be 2/5 instead. So you can write these in any order. It doesn't matter, just make sure you hit all of them. And now we're going to do the opposite. So now we get a description and I want you to write the equation. So we'll just go through this step by step. So vertically compressed. So automatically when I hear compressed, I'm thinking it's a fraction. So by a factor of 5, that makes sense because since it's the reciprocal, we're going to have a 1/5 in front of here. Then it says translated 4 units to the left. So since it's to the left, you would think -4, but the right and left is opposite signs, so we're going to have a +4. So that +4 goes in the parentheses because that's what moves it right and left. You always have your squared. And we hit everything else. So our equation is y equals 1/5 times x plus 4 squared. On to the next one. Vertically stretched, so automatically thinking it's a whole number because that's what makes it more narrow. By a factor of 1/4, we want to flip that. Our reciprocal of 1/4 is 4. And translated up 5 units. So it's not moving left or right, so we don't need any parentheses. We just have x squared. And then our +5. Here, reflected over the x-axis, we're going to have a negative sign in front, so y equals negative something. Translated 2 units to the right, so since it's moving to the right, you think +2, but it's negative because it's opposite, so that goes in your parentheses. And then 1 unit down always goes on the outside. So we get y equals negative times x minus 2 squared minus 1. Last one that has a little bit of everything. Reflected over the x-axis, we automatically know equals a negative. Vertically stretched. Stretched means it got more narrow and tall. So I'm thinking a whole number. By a factor of 1/6, the reciprocal is 6. Translated down, or translated 2 units left. So 2 units left, I'm thinking -2 opposite. So we get x plus 2. Don't forget your squared. And then 5 units up, we just have a +5 on the end. So when you're writing the equation, it might look intimidating, but just go through it step by step. And we will practice more of this graphing tomorrow during class. Make sure you come to class with any questions you have.